To give us this curve, first part just says show what the derivative is equal to. So I feel pretty confident if I do the derivative, I get that as the answer. All of that work there is the justification. So I factor out, not really, I just left the constant in front. And I did a product rule right there. So first times the derivative of the second plus the second times the derivative of the first. And then the derivative that was 0. Did my easy power rule. Just remember when you take the derivative of y's, you got to tag on the y prime. So do your implicit differentiation. And then I went ahead, I just distributed the 6. And I grabbed all my y primes, put them on the same side, factored out the y prime and divided. And then I did like a GCF. I pulled out a 3 here. So then -6/3 gave me that -2 in there. And then that wasn't quite the original problem there, but that was reversed. So if you just factor out a negative, if you factor a negative out of the bottom, and then those negatives cancel right there, or if you just take the negative and stick it on the bottom, that makes it a -2x and a positive y squared, and it switches the order of that. And then I showed an alternate way right here. If you took all your y primes and moved them to the right and then solve for the y prime, you still get what they kind of have right there. So kind of just make sure you practice the derivative work by yourself there, but that could be something as long as you do your product rule and do your implicit differentiation. Remember to tag on your y primes. We should be good there. All right, now part B says find the coordinates. Now, when it says find the coordinates, eventually that means we got maybe like take something and plug it into the original function. All right, but first it says where the line tangent to the curve is horizontal. So when you see tangent line, you gotta be thinking derivative. Horizontal tangent line, that's where the slope is equal to 0, which means the derivative is equal to 0. So right away I set my derivative equal to 0. And then this is your derivative from part A. You can just use that and set it equal to 0. Now, a fraction is equal to 0 where the top is equal to 0 and also where the bottom is not equal to 0. But so if you just set that top part equal to 0, that gives you y equals 0. But then when it says find the coordinates, we got to know that means plug that into the original function. So if you get first, you'll get something if you just set the 2y equal to 0, showing them that you're setting derivative equal to 0, and then you get that y equals 0 number, and then take the 0, plug it in for these y's into the original function. Although I was hoping maybe, okay, when I did that, maybe I get something with an x, but when I did that, those just all like went to zeros, and I got 0 was equal to 2, which is not true. So that's just no solution for that equation. So that just means no point exists there. Now, I thought I had to explain something. You didn't need to explain any of that. As long as you show work, you plugged it into the original and you didn't get something like if you would have gotten x equals something, then that would have been your point there. And also it does tell us like find it or explain why no such point exists. So it's okay to get that. So again, horizontal derivative is equal to 0, set that derivative equal to 0, and then whatever you get there, plug it into the original function because they want the coordinates. That means on the original function there, but I wasn't able to solve that equation. That was no solution, so no point exists. Part C says find the coordinates where the line tangent to the curve is a vertical. All right, now we have this fraction for the derivative. You're going to have horizontal tangent lines where the derivative is 0. That's where the top is equal to 0. And then you have vertical tangent lines where the slope is undefined, where the bottom of the derivative is equal to 0. So set the bottom of the derivative equal to 0. That gives us this y squared equals x over 2. And then again, when it says find the coordinates, they're meaning for you to plug something into the original function. So either get x equals or y equals and plug that into the original function. So I just right away, I didn't feel like messing around with those square roots or anything like that. So I just did x equals y squared over 2. And I plugged that y squared over 2 in for the x into the original function. And you kind of see my work there where I just solved that for the y. And then I plugged that back in and I got the x. So I got 1/2 and 1. And I did check that at the bottom here. Like if you plug it into the original function, you get 3 equals 3. And if you plug that point in for x and y into the given derivative, I did get 0 for, no, I'm sorry, I plugged it into the bottom of that derivative and I did get 0 on the bottom of that derivative right there. So vertical tangent line because the derivative is undefined because the bottom of the derivative is 0. And then that's where, it did work in the original function as well. So they want those coordinates, so that's our answer. All right, now the last part, looking like a little related rate there. So we're just tagging on dy dt and dx dt, but they pretty much give us what we need. We have the original function, and they said the horizontal position is increasing at a rate of dx dt is equal to that. What's the value of the dy dt. So we have xy, we have dx dt. They just weren't asking us dy dt. You guys know how to do this. Just when you start seeing that stuff, that's just tagging on your dx dt, dy dt, basic related rate problem there. So again, the constant I just pulled in front, I did the derivative of everything. So the derivative, that is my product rule. But instead of just doing xy prime, you're doing it with respect to time. So that's going to be first times the derivative of the second, that's a dy dt, plus the second times the derivative of the first. The derivative of x with respect to time is dx dt. And then the derivative of that is still 0. Do your power rule, but you're taking the derivative with respect to time. Derivative of y is with respect to time, so tag on the dy dt. And then everywhere you see an x, you're going to plug in a 1/2. Where you see a y, you're going to plug in a -2. The dx dt, you're going to plug in the 2/3. And then just plug that stuff in and be really careful. Practice this without the calculator and just solve that for the dy dt, and you're done. All right, so let me know if you have any questions over that. Make sure you practice all that by yourself. Coconut.